Good evening.
Hello, good evening, sir.
Yeah, good evening, everybody.
Yes, sir.
Trust your day was good.
Yeah, very good, sir. Thank you, sir. Hope yours was
Yes.
good out there, sir.
Yeah, I'm fine also.
Yes, sir.
We thank God for tonight and another opportunity to come together to have some words and teaching and also brainstorming on the topic that we have started about. Going to 3 weeks or 4 weeks now. Yes, I think 3 weeks or 4 weeks that we have started. The topic is fundamental skills in audio mixing and techniques for digital mixing console. And I believe that one way or the other, we have been gaining from this lecture and from this training. I also want to believe that it is highly expedient that we also have a jotting material where you can put one or two things down that will also help you to be able to come back and check on what we have been discussing. Tonight, we would like to move a step forward and go to the next topic. And last week, we stopped at, if I could remember vividly, we stopped at equalization. What is equalization? What is equalization? I remember that's where we called it a day last week. Yes, the equalizers. What is equalization for? What are we making equal to what? This is a very, very, very great and sensitive question. Very, very sensitive question. What is equalization for? What are we making equal to what? Now, equalization is all about cutting or boosting band of frequencies with respect to other band of frequencies. So what are we making equals to what? That is a good question. To answer this question, we have to go back. Yes, we have to go back and the earliest practice of sound in history, and also the earliest practice of sound in engineering when the earliest practice of engineering was when it was discovered that a telegram cable used for sending simple electrical pulse in a Morse code could be used to transmit speech over long distance. One of the problems was that that level was lost over long distance. To combat this, amplifiers were placed along the way to boost the signal back up again. Let me just quickly, explain this to us so that we can understand. You see, just like it has been stated, I believe many of us may not be able to broadcast, but this thing is just the same thing like happened in broadcast. When NTA started transmission, they only have one NTA station then, which is NTA Ibadan, which was NTA Ibadan. And as of that time, they have some other stations that they want them to receive the same signal all over the country. So what they did was they started building some booster transmitting station. Wherever the signal gets to, when it's like it can't boost again, they built another booster station. That was exactly what this scenario was explaining to us about equalization and what Telegram does then for telephoning, because that was what was initiated then. So for them to be able to meet up, that the signal didn't drop at a particular long distance, no, the distance travel with time. So they have to like build something to boost the signal up again periodically where it drops. Now, this is just to tell us what brought out the idea of equalization. For a long time, this was what equalization was used for. Even when into the era of recording and broadcast, just like I've explained, equalization was used to correct frequency response problems. Equalization was used to correct frequency response problems where and when they occur. But then, at some point, some bright sparking recording or broadcast engineer must have fiddle and EQ control and thought, hey, the sound, that sound nicer, you know. So rather than using equalizer EQ to correct a problem in frequency response, it was used to improve the sound subjectively. So no longer was the output equal to the input, it was enhanced over and above the input. Thank God we dealt with frequency response last week. So, and everything that we have talked about frequency response, your low, mid, your subbars, your sibilants, that's your presence, your mid-range, low mid-range, and also the high, where we have the presence and the brilliance. We talk about the frequencies that are responsible for all this. So it is very important that I believe that all engineers must know their frequency from 20 watts, 20 hertz to 20 kilohertz, which is the sound that is audible to human hearing. That's the frequency response that is audible to human hearing. That's why you see on our equalizer, they write from 20K to 20K, 20 hertz to 20 kilohertz to make sure that every frequency that is audible to human hearing is not missed out. Now, with this, moving on to today, just like I was explaining before, we use EQ in both of these ways. They are very, very important. These are the two ways EQ is being used. Firstly, as a corrective tool to compensate for frequency response irregularities caused by inadequate equipment or less than satisfactory equipment or poor acoustic or microphone positioning. When we have done that, we go further and use it creatively. You use it creatively to enhance the sound to our liking. So you can see that equalizer is used for both corrective and also for creative. So if you want to use your equalization, it's either you use it to correct an error from the irregularities of your equipment. You know, most of this equipment we are having now, they are China products. And their frequency response cannot be what they put on it. So you need EQ in some area to correct those irregularities in the frequency response of those mics. And just like we have said all the other before, even in keyboard, you use it to make correction when you have feedback. Equalizer also is used to correct all those issues. And you can make it creative. Like when you are talking of a talking drummer and you want to add an EQ to that particular microphone line. I'm not talking about the parametric EQ. I'm talking about the graphics EQ in the digital system that is assigned to that particular channel that you have your input of your talking drum microphone. You can now use the EQ to also creatively make the bass, the sub, and everything, you can tighten up and put some effective, creativity on it so that it can sound better. You can also use it for keyboard. You can use it for digital. Even, you can use it to create your output, your master output. You can EQ it by making sure that you want the sound to be more, tight. You can do whatever you think is more creative. That's when you have the approach of the corrective measure before. Now, moving forward, the best known and most commonly signal processor that anybody, any engineer, sound engineer can talk about is the equalizer. We use it like no man's business. I believe you all agree with me that equalizer is one of our prominent tools in sound engineering or for audio engineer. For those of us that will do rigging, that will do setup, even in studios, there's nowhere, even if you don't have compressor, if you don't have crossover, if you don't have limiter or gate, you must have equalizer. You just must have equalizer. And I discovered that it is something that is commonly all around. You see it in our rack. Some people carry it, they rack it separately. And if not, you find it on some console. You find some parametric EQ on some console. So an electronic device that alter the frequency response, mind you, that alter the frequency response by increasing or decreasing the level of a signal at a specific portion of the spectrum. You see, if you don't understand your frequency response, it may be very difficult for you to apply equalizer, especially on digital console. Because right on digital console, they give you the frequency range from 20K to 20 kilohertz. And if you are very good with your frequency response, you know what you want to do, you know what you are mixing, is a bass jitter you are mixing. For Christ's sake, if you are mixing a bass jitter, what is 4K or 8K or 10K doing in your bass jitter? You want to tighten it up? It doesn't work in that frequency. Bass doesn't work in that frequency. Or you want to mix a saxophone, for example, with a mic, and you are working towards the 60, 50 hertz, 63 hertz, where you have the bass end. Saxophone doesn't need bass like that, for Christ's sake. You can't do anything within that frequency range. Or is it not the jitter that you are trying to work with the range where you have the low end, where you have the bass, the 50, the 40, the 25 hertz? No. Okay, the 25, it can't work. You can't hear it. In fact, you make your lead jitter sound muffled. So all what we are trying to lay emphasis on is that the foundation was laid last week concerning frequency response, which is very important that we know our frequency spectrum response for human audible hearing. Now, looking at this critically and looking at the way is moving, an electronic device that alters the frequency response by increasing or decreasing the level of the signal at a specific portion of the spectrum is known as equalizer. This alternation can be done in two ways: by boost or cut. Mind you, by boost or cut. So how do you know when it is time to cut? How do you know when it is time to boost? That is what your frequency response and spectrum analyzer can do for you. Or frequency spectrum analyzer, it can do for you. It tell you the particular frequency you need to cut and the particular frequency you need to boost. For example, for voice, you may have to cut some frequency at 1K or 2K or 3K. If you want it to be tight, you want the voice to stand out, you may have to boost at 4K. You may have to boost close to 5, 6K for your frequency for voices. So you must understand what and what you are organizing towards.